Do you have a brain blood flow disorder? What are the most common diseases linked to chronic brain hypoperfusion, and what can you do about it? It's called vascular cognitive impairment, for lack of a better word, and we're going to talk about a couple of them. Chronic cerebral hypoperfusion, CCH, is a condition characterized by reduced blood flow to the brain over an extended period of time, and that could be just minutes. It is implicated in various central nervous system diseases, including vascular cognitive impairment, dementia, and Alzheimer's disease. Understanding the pathologies related to chronic cerebral hypoperfusion, or a brain blood flow disorder, is crucial for developing therapeutic strategies to reduce or mitigate these effects. Chronic cerebral hypoperfusion, or brain blood flow disorder, can be related to hypertension, high blood pressure, can damage the blood vessels and reduce blood flow to the brain. Atherosclerosis, the buildup of plaque and blood vessels, can restrict blood flow and its inability to vasodilate. Diabetes, high blood sugar levels can damage blood vessels and reduce blood flow. Smoking can damage blood vessels, reduce blood flow, and reduce oxygen because there's carbon monoxide in your brain. Obesity, excess weight, can increase blood pressure and reduce blood flow. Sedentary lifestyle, because the lack of physical activity, can reduce blood flow and contribute to this hypoperfusion. And risk of aging. There's not much you can do about that, because this perfusion is reduced in aging. In my book, My Brain Matters, the neurometabolic solution, I go deep into this because oxygen is important for a neurometabolic solution. And we worked a lot with Jacques C. Delatour's work from way back, where he looked at cardiovascular risk factors promote brain hypoperfusion, leading to cognitive decline and dementia. And there is a list, more profound list, of vascular risk factors for Alzheimer's disease and vascular dementia. So any type of accelerated aging, if you will, when there's risk factors for Alzheimer's disease or chronic cerebral hypoperfusion or brain blood flow disease, you're going to have altered cerebral hemodynamics, chronic cerebral hypoperfusion, cognitive decline, and Alzheimer's disease. And that catch right in there, that is, when you're looking at blood flow perfusion, stands for critically attained threshold of cerebral hypoperfusion. And what does that mean? It means that every brain has a limit to how much hypoxia, or lack of oxygen, it can take. Like a stroke will affect the oxygen in this level right here. But if you have poor perfusion throughout the whole brain because the blood's not pumping in there, then the whole brain can be damaged. And this can be a chronic, ongoing state, like hypoxia during sleep apnea. So this is what he looked at, this cardiovascular disease cascade, as it relates to cognitive decline or brain fog. So when you have cardiovascular dysfunction, you have disturbed hemodynamics, decreased cerebral blood flow, hypoperfusion, decreased energy substrate. Then you're going to have proteinopathy and A-beta misfolding and decreased clearance of the A-betas and various toxins in the brain, which we're going to talk about. And then everything starts to go down, cognitive decline. And if you look at it, global brain hypoperfusion and oxygenation in memory loss, mild cognitive impairment. This is the deal here. That global brain hypoperfusion is a brain blood flow problem. And their little description of chronic cerebral hypoperfusion is similar to what we're going to talk about, vascular cognitive impairment, is you have risk factors and then You have disease, and then you have injuries, and then you have pathologies, and then you have vascular dementia or vascular cognitive impairment. And these are small things, but this is a loss of cerebral perfusion. It gives you a loss of cerebral function. And the blood flow makes these neurons fire. But if you don't have ability to make ATP energy, then everything goes down and the brain starts to slow down. And that's the situation. And this creates an inflammatory state because the neuron is injured, doesn't have oxygen. It starts to become injured just like a stroke. It's just smaller areas slowing down. And this whole system of glial activation and pro-inflammatory cytokines, and down you go. And as you have oxidative stress, decreased ATP production over here, mitochondrial dysfunction, hemodynamic dysfunction, the whole scenario starts to spin down and you have more inflammation than you really need, and that slows the whole thing down. So as the brain perfusion goes down, brain function goes down. And that's the whole point of it. So if you have hypertension or restriction in these blood vessels, you see, this is normal flow into these small vessels. And in Alzheimer's disease, you have lack of good blood flow into the brain. And that is brain blood flow disease. Brain blood flow problems. And that can lead to this inflammation, vascular dysfunction, and the blood-brain barrier gets messed up, and then you have neuroinflammation, hyperperfusion, dysregulation of the blood flow, and it's just common that you're going to have cognitive decline. So if you use transcranial photobiomodulation on the brain, we can stimulate these blood vessels to open up, these very small blood vessels. That's the antidote. And if you look at it, you have large arteries outside here, right? And then they get smaller and smaller. So you can see any restriction in the big vessels can create profound hypoxia, hypoperfusion in the small areas deep in the brain. And you can see that these arteries are big and then they get smaller and smaller. So transcranial photobiomodulation can help vasodilate and change this brain blood flow dysfunction. At photobiomodulation vasodilates these arteries and allows for increased blood flow to the brain. But what happens if you put the light on the large arteries of the neck, extracranial arteries? Okay, this is what we propose as a therapeutic intervention. Put both of them on, neck and brain, because carotid stiffness in the neck is associated with brain amyloid beta plaque burden in memory loss, cognitive impairment. So it's the vessel dysfunction, the cardiovascular disease affects all these tissues. And these are the big arteries that run up to the neck. It's the only place the brain gets its blood, from the heart to the neck to the brain. And so why don't we use photobiomodulation on the extracranial cerebral arteries of the neck to boost this flow? Think about it. These arteries are what give blood to the brain. And if you're just working on these thin arteries without increasing the blood flow in the neck, you may not have a therapeutic dose to change these things. So that's how we do it. Put the light down here, vasodilate these so that these have more blood flowing into it so that they get vasodilated too. Because that's how it works. Photobiomodulation works for nitric oxide release to create increased cerebral blood flow and oxygenation. And it helps if you do it on the neck first. Okay? Because this will create smooth muscle relaxation when you put photobiomodulation there and creates vasodilation to the brain. So why not do it in the neck? And this is what happens is in the brain, when you put the light on, you have increased blood flow because you have increased vasodilation. So support that brain blood flow problem with the neck. We also have a lot of lymphatic vessels in the neck that we can activate. And at the same time, veins in the neck that we can activate, as well as these nerves in the neck, which is called vagus nerve stimulation. So I want to thank my scientific board as we helped us to express these perspectives on brain blood flow dysfunction.